Okay, the next toolkit entry in geometry for Chapter 5 is Rationalize Denominators. And the first statement up here says, it is common practice in mathematics to not have radicals, which are known as square roots, in the denominators, and those are the bottoms of fractions. So you'll see in both these cases down here, there's a square root in the denominators of the fractions. And it's, like I said, it's common practice not to have that. You want to have the square roots on the top, but not the bottom. And so if we want to remove those square roots, that process of changing those radicals into whole numbers is called rationalizing the denominator, where the denominator becomes a rational number. The square root of 5 is not a rational number. It's what we call an irrational number. Same thing down here. Square root of 2 is what we call an irrational number. So here's the trick. Here's what you do. If this was the square root of 4, we'd be in business because the square root of 4 would be 2. But it's not. It's the square root of 5. So what you want to do is you want to look at the bottom of your fraction and then multiply that bottom times itself. So by doing that, what happens is you get the square root of 5 times the square root of 5, which is the square root of 25. And what is the square root of 25? Well, it's 5. So if you multiply the bottom by the square root of 5 in this case here, you'll get a nice whole number, what we call a rational number. Now, if you multiply the bottom by the square root of 5, you have to multiply the top by the square root of 5. So that becomes 8 times the square root of 5. Can't do anything real special with this. We just leave it alone here. So the final answer ends up being 8 square root of 5 over 5. So this is a case where we have the square root has been moved to the top, and you cannot reduce 8 over 5. Now, in the next problem here, we have a square root of 2 on the bottom. So to remove the radical off the bottom, we're going to go ahead and multiply by the square root of 2. Do the same thing up here. So 6 times the square root of 2 is 6 times the square root of 2. Can't do anything with that. Now the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2. Now the one thing you can do in this case is if you look just at the whole numbers, not at the radical, but if you look at 6 and you look at 2, what number goes into both these? Well, they're both divisible by 2. So if we divide them by 2, we get 1 here. If we divide this by 2, we get 3. And so the answer ends up being 3 square root of 2 over 1, which could just be written as 3 times the square root of 2. So not only we rationalized it, but we've also gone ahead and simplified it as much as possible. So the final answer ends up being 3 square root 2.